Okay, we're going to take a look at a motion question. This is from the 2012 AP Calculus AB exam, and this was question 6 on the free response section. That means that it's a no calculator question, and you'll notice a common theme is they like to put trig functions in wherever they possibly can. So this does involve a trig function, and therefore it can be a little bit confusing. So we'll work through that. Also in the process, we'll work through some of the concepts here. I would actually say that A and C are not new questions for us. B and D are going to be new from sort of our integration unit that we're working in right now. And A and C really aren't involving integration at all. But like I said, they do get confusing with the trig. So please, as always, pause the video, try it yourself, but use this to check and or help you when you're having troubles thinking through things. So jumping right in. Part A. We want to know, when is the particle moving to the left? So the first thing that I'm thinking is the concept. How do I know when it's moving to the left? And finding positions here is not going to be effective. You're going to have to do a whole bunch of, unless you could graph the entire function. But we have a velocity function, so let's think about how a velocity function can help us. Sign of velocity tells us direction of movement. So a negative velocity is going to be when I'm moving to the left. Now, that's not giving me any points. That's just me kind of thinking out loud. But generally speaking, I should put my work down below or in the boxes that they're going to provide for you. So in order to figure out when the velocity is negative, well, I need to know when the velocity is 0, because those would be the potential turnaround points. So I'm going to start by saying, when is the velocity equal to 0? And that's going to be when cosine of pi over 6 times t is equal to 0. And this is a little bit maybe confusing. I'm going to ask you to think back to your previous course, pre-calculus course, and you probably did u substitutions for this and maybe simplified this to when is cosine of u equal to 0. And that would be when u is, so now I'm thinking unit circle, cosine is 0 here and here, which would be pi over 2 and 3 pi over 2. I'm looking at the interval and I'm working from 0 to 12. So I'm going to start with those, but I might need to consider other values, as in 5 pi over 2 and 7 pi over 2, etc. But then what I'm going to do is I need to figure out what t is. That's just my u value, and I did a substitution here. And my t is this pi over 6, or my u is pi over 6 times t. So I'm going to replace this u with pi over 6 times t. And you might not do the actual substitution. You might just figure out that, okay, whatever that is equal to 0 when I've got, when it's at pi over 2. But if you are doing this, I'm just taking that and now substituting in for my u, pi over 6 times t. And then I'm going to do the same thing. I have multiple equations here. Pi over 6 times t is equal to 3 pi over 2. Pi over 6 times t is equal to 5 pi over 2. And pi over 6 times t is equal to 7 pi over 2. So I might not end up needing all of these, but I have no idea what my t is going to come out to be. So at the end, I'm going to check that interval. So now I'm just solving those. And solving those is going to be multiplied by the reciprocal. And that gives me time equals, pi's cancel out, 6 over 2, which is 3. This one's going to give me, when I multiply by the reciprocal, again, the pi's cancel out. 6 times 3 is 18 divided by 2, 9. And that's going to give me 30 divided by 2, which is 15. So now I can see that that's already outside of my interval. Remember, that interval is from 0 to 12 is what it tells me in the very top of the problem. And therefore, that one's also going to be outside of my interval. So I have time equals 3 and time equals 9. But let's remind ourselves, what did we do? We found when the velocity was equal to 0. So I actually don't know anything yet as far as the question goes. Moving to the left, I need a negative velocity. So I need to do a little bit more work here, and there's multiple ways that you can think about this and set this up. My choice is going to be the number line, same number line that we've used a lot. 3 and 9 are my critical points. That's when my velocity is equal to 0. And I want to figure out when my velocity is negative. So now I'm just going to test a couple points. So I'm going to test something before 3. So I'm going to go back to my velocity equation, which is that cosine pi over 6 times t. and I'm going to check 0 because I can, right? That's less than 3. So velocity at 0 would be cosine of pi over 6 times 0, which is really just cosine of 0. Cosine of 0 is 1, and so that's a positive value. So that means my position function is increasing, or in the case of horizontal motion, that means moving to the right. And I need to check 2 more intervals. So velocity at, I'm going to do 6. I could go anywhere between 3 and 9. I'm trying to work out something that works out nice in my head because, again, I'm not using my calculator. So pi over 6 times time, if I make my time 6, those cancel out, and I'm looking at cosine of pi, which is a -1. So I'm getting a negative value here, which means I'm moving left. And then I have a hunch that the next one is going to be positive, but of course I should check. Pi over 6 times 12. So again, these are my test values here, 12, 6, and 0 falling in here, those 3 spots. And 12 divided by 6 is 2, so cosine of 2 pi is, whoops, a +1, and I'm getting that positive value that I expected, which means it would be moving to the right. So, final answer for part A, yes, that was a lot of work. The question is, when is the particle moving to the left? So I'm going to go ahead and put when velocity is less than 0. And then I'm going to list that interval. It's between 3 and 9, or you could also write that as the interval between 3 and 9. Okay, notice that that is it only asks one question. It doesn't ask you to justify your answer, which means that it's either 1 point or this was a lot of work. So let's hope it's 2 points. It does turn out that it's 2 points. And the 2 points here come from 1 for your answer. And the second one is from considering when the velocity is equal to 0. So most likely if you had gotten to this point and gotten t equals 3 and t equals 9, that would have been 1 point if you weren't able to get to the end of it. Okay, so moving on. Part B. Write but do not evaluate an integral expression that gives the total distance traveled by the particle from time equals 0 to time equals 6. Key word there, whoops, is total distance. So I'm going to let you try that one and then check that. You could actually just go back, and it was on that rubric. Hopefully you didn't look yet. That is new, but we went over that, and I think you can figure that one out. So let's go on to part C. Find the acceleration of the particle at time t. Is the speed of the particle increasing, decreasing, or neither at time t equals 4? Okay, I'm hoping this question is starting to look familiar. Speed increasing, decreasing, or of course we have that neither option. Explain your reasoning. This is going to be at least 2 points. 1 point for your answer, and then 1 point for your justification with it, because it does have this explain. This one might be 3 points. Oops, I skipped B. Okay, so this is C. So it does ask us to find the acceleration at time t, and that's actually going to be a point right there. You'll start to notice when you read these that each sentence is a point. So they're actually going to give you a point just for finding the acceleration, and then they're going to give you a point for speed increasing or decreasing, most likely 2 for that, because it involves an explanation, would be my guess. We'll double check with the rubric in a second. So far we've got 2 points, 1 point. I'm guessing 3, and that leaves us 3 for the last part. So acceleration at time t, that means I need to do a derivative. So don't forget about good old derivative. You had your velocity function, and we're going to do the derivative. I'm going to go ahead and put that I'm doing the derivative of velocity, just in case it's just good to communicate what we're doing. And velocity was cosine, so derivative of cosine is negative sine. But really it's cosine u, and your u is pi over 6 times t. So u substitution here, chain rule. So there's my negative sine u, and then times u prime, which is pi over 6. So you might prefer to write that as negative pi over 6 times sine of pi over 60. It's probably the nicest form of that. Very common that they'll include chain rule in there. Okay, so then they ask us to find the acceleration they ask us to find the acceleration of the particle. So this should be 1 point right here. I'm going to make it obvious that I did that. Okay, now I'm going to answer the question, is the speed increasing, decreasing, or neither? And hopefully you're remembering, or pause, think about this. How do we answer this question? This is the one I keep harping on you that we need to get better at. We should be looking at sign of both velocity and acceleration. We're looking to see if they match or if they don't match. So finding just one is not enough. Sneaky, right? Now they're making us do twice the work. So we need to find the velocity and the acceleration at time 4. And I don't believe I've done either of those. I always check, like, did I do that in part A? Didn't do that in part A. So velocity at 4 is cosine of pi over 6 times 4. So that's really cosine of 2 pi over 3. And now I'm thinking of my unit circle. Do what you need to. Don't draw the whole unit circle, though. Pi over 3, 2 pi over 3 is right here. And cosine is your x value. So that's the short one. That's the 1/2, but it's negative because it is in your second quadrant. So I've got a negative x value there, negative 1/2. So cosine or velocity is less than 0 is my conclusion there. Now I'm going to do acceleration. And now I'm using this function. Again, plugging in 4. So that's a negative pi over 6 times sine of 2 pi over 3. Sine of 2 pi over 3 is my positive value here, radical 3 over 2. It's my taller side of the triangle. Longer side of the triangle is what I think of it as. Positive because it's in my second quadrant. My y values are positive. So I've got a negative pi over 6 times a positive radical 3 over 2. And again, don't do more work than you have to. We're trying to figure out if this is positive or negative. And at this point, we can say that's less than 0. Okay, so I really didn't even need to figure out the radical 3 over 2. I'm just used to getting that value. But we should be able to complete this problem in 15 minutes, and I'm getting close to 15 minutes. Of course, I'm talking through it, but just to kind of keep track of that. So I need to answer the question, so I need to write a sentence, and that sentence is going to be, I'm rephrasing the sentence. Is the speed increasing, decreasing, or neither? The speed Speed is increasing because velocity and acceleration are both negative, or velocity is less than 0 and acceleration is less than 0, however you want to say that. Have the same sign, any of those will work. Let's do a quick check with the Rubric. So part D, I did say, is a new part. Part D, find the position of the particle at time t equals 4. So this is going to be one of my new things based on integration. That's a hint. And B was the other new part. Find the position at time t equals 4. And here's why. I don't have the position function. I have the velocity function. Related to the velocity function, the position is the antiderivative. So I am going to essentially have to go backwards in this. There's another key piece of information here. And that would be right here. We haven't used this yet, and that's going to come up. Position at time 0 is x equals -2. So I'm going to think of this as my final position. That's whatever position I'm looking for is my initial position plus my change in position. So my final position, that's what I'm looking for. The final position is at time t equals 4. So position, whatever you want to use. A lot of times they'll do this, so I'll use this notation, x of 4, because if I'm moving horizontally, I'm moving along the x-axis. So It's kind of weird to think of that as my like y value, but that's a lot of times what they'll do. Initial position, not necessarily x of 0, at time 0. But in this case, that's what I know. They told me, go back to that given information that I highlighted at the top. At time equals 0, my position is -2. So I actually know that's the only position that I know. So that is going to be the initial position. Just know that doesn't always have to be a 0 there. Plus my change in position. Okay, now here we got to think. Change in position. Difference, that's the displacement. Difference from when I started, whatever my start time is, to my end. And that's where we're going to use an integral. Integral from 0 to 4 of my velocity function gives me my change in position. So I'm looking for position at 4, and now I need to figure out what is my, how do I evaluate the integral from 0 to 4 of my velocity? So integral, big idea. Integral represents area under the curve. I don't have that graph, so I'm not, and it doesn't seem like it's a nice graph in terms of straight lines that I can do geometry to get the area. So my next thought is, can't use a calculator, I know that's what you're thinking, is can I use fundamental theorem of calculus? So I'm going to kind of do a little aside here, and I need to find the antiderivative of this function. So antiderivative of my velocity function was cosine of pi over 6 times t. So velocity, let's write that here. Okay, so I'm trying to figure out my antiderivative, and I'm using some guess and check here. So I'm thinking it's sine of pi over 6 times t. Derivative of sine is cosine if I go backwards. So that's checking out, right? Because if this is my position function, then I take the derivative and I get this. But because there's a chain rule there, I've got sine of u. Sine of pi over 6 times t, then I would have to multiply by pi over 6. So my derivative would actually be cosine of pi over 6 times t times of pi over 6. And notice my velocity function doesn't have a pi over 6. So I need to get that to cancel out, which means I can't change the velocity function because that's given. I need to get that pi over 6 to cancel out, which means I needed to have a 6 over pi there. If I had a 6 over pi there, then those would cancel out and I'd get right back up to that velocity function. So I'm going to remember, this is my guess right here. My guess, I'm going to change to 6 over pi times sine of pi over 6t. If that was my function, if this was my position function, take the derivative, 6 over pi, constant out front, stay there, times cosine of u, times u prime, which is the pi over 6. Okay, so that's a little bit harder of a working backwards question than what we've done, but we will get better at that as we practice it more. So I did successfully figure out my antiderivative right here. So applying my fundamental theorem of calculus, that's going to be antiderivative, which is 6 over pi sine of pi over 6t, evaluated at 0 and 4. Take the difference between those two. So that's me doing this, plug in the 4. So plug the 4 in first, and then 6 over pi times sine of pi over 6. Plug the 0 in, and subtract the 2. So this is all my fundamental theorem of calculus. I'm getting one number there, and then I'm going to add that to this -2 that I'm bringing down. Okay, so evaluating this. 6 over pi times sine of 2 pi over 3 is what this ends up being. So sine of 2 pi over 3, I did that a minute ago. That's radical 3 over 2. So that's going to be 6 over pi times radical 3 over 2, which is 3 radical 3 over pi. Wow, lovely numbers, right? Minus, this is going to be a 0 right here. Sine of 0 is 0, so this whole thing's going to be 0, and I don't need to worry about that. So my answer We don't worry about rationalizing things in this class. Position at 4 is -2 plus 3 radical 3 over pi. You're thinking, holy cow, that could not possibly be the actual answer to that question. Makes sense? One other way to set this up, if we go back to this original setup right here, I think that probably made sense from a conceptual standpoint, but there's another way to look at that. And I'm going to try to squeeze it in on the screen here. What you could have done is you could have started with the integral from 0 to 4 of velocity. And if we were just thinking about how do I conceptualize and interpret that integral, I can use fundamental theorem of calculus, thinking of that as my derivative function, x prime of t, would give me x of 4 minus x of 0 by fundamental theorem of calculus. And I want you to just stare at this for a sec. And just notice that that is literally the exact same thing that we have right there. All I did is add x of 0 to the other side. So the x of 4 is by itself. And then I've got x of 0, position at time 0, plus the integral from 0 to 4 of velocity. So that would be a totally acceptable way of setting it up. Either way, you'll be solving for position at time equals 4. So it's whether you want to set it up, solve for that, or solve for it later. Hopefully that did help. Sorry, that ended up a little bit long. Goal is 15 minutes per question. But like I said, I was talking through that, and maybe you flew through it a little bit quicker than me. This is the rubric, the AP rubric. So let's just take a look at A. Just looking at this section right here. And here's those 2 points that we just talked about. And obviously they have a little bit less work than us, but I think it's expected that you would do more work there unless you can do stuff in your head. Okay, so if you didn't check B, there it is, and C. So we got less than 0, less than 0. That's matching with what we did. Speed is increasing because velocity and acceleration have the same sign. So we had almost the same sentence as that. 3 points, 1 for the acceleration, 2 for the conclusion with the reason. So I was right on with that. And one more part. Just so you know I'm not crazy. -2 plus 3 radical 3 over pi. There it is. 3 points for this. Let's take a look at where you're getting the points here. 1 for using the antiderivative, 1 for using the initial condition, and 1 for getting the answer. So even if you did mess up the antiderivative, you'd probably get at least 1 point if you did consider that initial position, that -2. I'm going to show you one other way to set this up. Hopefully that's a quick heads up. The next question that I'm asking you to do is a calculator question, number 1 on the AP exam. Free response is always a calculator question. So please do make sure your calculator is in radian mode for this one. And some of the things are going to be similar. Some of them are going to be a little bit different, so read them closely. If you're looking for which ones are the new ones, B and C are new from this chapter. A and D are actually review questions. No, actually D is new too. I'd say D is going to involve some new stuff. So actually B, C, and D are new, A review. Not too much work you're going to be doing. That one's going to be more thinking through the concept, but you please use your calculator and remember to round to 3 decimal places also. And then the last question here is another question that involves motion. This time you've got a graph. So we had a table, we have a couple that just had a function, and now you've got a graph. So really good sort of variety of questions that you might see when you're working through this one. This is also considered a calculator question because it's a number 1. And I'd say the new parts here are B and D are going to be the new parts. Please attempt all of them, but just note that A and C are going to maybe involve, you might feel like they're easier, or maybe you're going to have to do a little bit of review. Okay, hopefully that helps. We will certainly discuss anything you're confused on, but please give this some good effort.